Sorry, I think it changed some of the permissions once the recording started. Um, right, here, let me share my screen again. Can y'all see that?
Yep.
Okay. Yeah, so these are, I'll try, I'm gonna zoom in a little bit here. So these are annotations that were made by the actual model. And this is a YOLO V11 um just like model that was pre-trained on I have it in my notes somewhere. I think it's the Coco data set. Let me see. So this is like so these are the true values. So these are images that I annotated with these bounding boxes. And then I'll show you the prediction from the model. So you can see here, like it's missing quite a bit of quite a few annotations. Um, and the confidence is pretty low.
Mm-hmm.
And then there's a few, I mean, I can pull up some of the actual like art results. So yeah, like the recall statistics just weren't really where we wanted them to be. So Naveed suggested that we transition to using image data or video data, and he recommended a few different kinds of models for us to try out. So I'm working on just like because obviously all the image annotations are pretty easy because it's usually just like one frame at a time, and we were sampling frames, so it wasn't very many. But I've been working with video data now. Let me see if I have a good one here. um, Yeah, so I'll just play the video, and this is just going through frame by frame and adjusting these bounding boxes to
Oh,
capture.
this is great.
Yeah. So that's that. So that's what I've been working on just this week, just trying to get some videos together
So
to
you're
feed
saying
into our models.
video is much more efficient than the image, you mean? Because of the moment.
Yeah, so we think the videos will be I think it'll be more computationally expensive to do, but
Yeah.
there's a whole other dimension of time to data that we can look at the motion between images that should help us identify where the bird is.
Okay.
So I'll
Sounds
stop
great.
sharing my screen. Yeah.
Yeah, I just wanted to jump in and check something with you, Pranav. Do you know if Freeman is in today?
So Ben is away for next 2 weeks. He's gone down to Costa Rica for field
Okay.
work. So he'll be back just before my qualifying exam on maybe March second week.
Oh, wow.
Yeah.
Yeah, that solves something, because we were supposed to have our meeting with him and the comp advisors
Yeah.
today. But if he's in Costa Rica, that's probably why he wasn't able to come. But perhaps I think you are not added onto that meeting, so perhaps I should add you to that meeting.
Mhm.
And then if he's not able to come, then you could like come in.
Okay.
So we were
When
supposed to
is the
have
meeting today?
it was 12 today, but would 12 next week work for like rescheduling that?
Yeah. Okay.
Cool. Yeah, because I think it's good for them to also have some conversation with you guys, make sure they're advising in a way that's, getting the kind of results you want.
Okay. Yeah. Sure. Thanks. That'll be great.
Awesome. Yeah, the other thing I wanted to hear from the audio people, because I wasn't able to touch base with their advisor yet, so I wanted you guys to give me a quick update on where you guys are at with that.
Sure. Do you want what we've done so far kind of update?
Yeah, so the last thing I heard from your advisor was you're using BirdNet to detect the sound of the bird that we're interested in, and then you're using an additional model to get the buzzing sound or to train for that buzzing sound. So I don't know if you have
Yeah.
results for that yet, but I understand that's what you were trying to do.
Yeah, so we haven't started working on the model yet. We were kind of still playing around with BirdNet and seeing the different confidence levels. And we were also using the data that Pranav provided us, like what species are most likely to be in that area, and then kind of using, and let me share my screen. I actually have a few plots that I um, put together so we can kind of walk through this a little bit. Um, so BirdNet will give us all of this information. But we added, so we kind of processed the data. We added like the time and the date, the location, elevation, and then based on the list that Pranav gave us of local species, we gave like a binary value. So if that species is known to be in that area, it has a value of 1. If not, it has a value of 0. Um, and these confidence levels are based on the confidence of the BirdNet algorithm. We are still trying to figure out what that confidence means, like what sort of, uh, I guess, rules that they're using to determine that. But we're still comparing different threshold levels just to see how accurate BirdNet is as a tool. Let me scroll down and show you guys a little more. This is a species distribution analysis. It's basically show you, what species are in the area. Naturally, the 0.5 confidence data set's going to have more variability. There's going to be a lot more species likely to due to a greater number of detections, and more likely to have misclassified birds. But it does show Humes as the second most common, and I almost wonder if this data is telling us if these other warblers have similar sounds to the Humes and if they're being misclassified in some way. And Pranav, we can maybe talk about that. I don't know if we want to talk about this meeting or not, but
Yeah.
um,
I mean, they do
yeah.
have
So
different calls, so I think you're
mhm,
doing good. I think the model is
okay,
doing good. But is this coming from one audio mod or multiple audio mod data?
this is all of the audio mop data together.
Okay.
Yeah, so this is all of the, but I do also have, so I took out just, let's see, I can kind of show you a little bit more. Um, I also looked at the elevation distribution of the most frequent bird species. So, and I know that we don't have all of the high elevation ones, so this isn't really a complete
Yeah.
analysis of all the data, but this is kind of what we started with, right? And so once we get all of the data, we can make like complete plots. But this, shows most of the species you're seeing at lower elevations. Um, we also kind of did some trending data on how active the Hume's warbler is, like what time of the day are they singing. What else? Oh, and we compared the confidence levels of BirdNet just to
Mm-hmm.
kind of give us an idea of um, misclassification. I mean, it's good that unexpected species lowers with an increased confidence level. That just goes to show how, I guess, the accuracy of BirdNet,
Yeah.
um, that it's reducing noise as confidence is raised.
Yeah.
Um, but I guess what we wanted to talk to you about is the ideal confidence threshold. Um, this is just song length and how
Yeah.
often, how long the seconds are for Humes. I'm not sure how that'll help us later, but that's just good to know. Um, uh, yeah, so this shows us the percentage versus the confidence threshold of BirdNet. So um, the species that are unexpected in the area,
Mm-hmm.
it'll decrease with confidence increase, which makes sense.
Yeah.
And then the expected will increase with confidence, which makes sense. But Hume's is kind of consistent across, so we're almost wondering, what do you think would be um, a confidence threshold that we're comfortable with? And I can
Yeah.
go through a
I
bunch
mean,
more
can
data with you and have a more robust conversation. But this is just kind of high level what we're seeing, and this is like the trend we're seeing.
Yeah. I was wondering if we can manually check the data for some, let's say we run, let's say 100 uh, audios through BirdNet, and then BirdNet, let's say, identifies 50 have Humes in there. and then we sort of manually go through them and see if BirdNet does well, and then we can figure out what's the confidence we need.
Oh, I see. Okay. Okay. So like manually see what is, and the other thing that Andre noticed is that, let me show steer. Um, like we'll have maybe like a 28-second length thing,
Hmm.
audio file, and BirdNet will split it up by 3 seconds. And
Okay.
it'll be the same bird for the majority that's detected in that block of time, but then we'll see like a random different bird in the middle.
Yeah.
And we're almost wondering, is this something that is like a mistake that BirdNet is making, or is this actually another bird? So just stuff like that,
Yeah. I
where
mean, I
mistakes
think
can be made.
yeah, I think for that for those cases, I think we need to manually check whether there are two birds singing. So if you can send me that small clip of, sound, then I can listen to it and tell you what species are singing. And then we
Okay.
can match with the predictions of the model, whether the model is doing better or not.
Okay. Um, okay, cool. That's kind of think.
So the question is, we can manually check out, like, let's say, like few audio chunks, but
Yeah.
we have like thousands, like
Yeah.
thousands. So the observations is like, if you go like 0.5 confidence level, we have 1.5 million observations. A lot. I mean, not a lot, but a lot for manual
Yeah, 100%. Yeah.
checkup. So, and in this case, probably we of course we're gonna listen to you as the expert and see, okay, like in this case, it seems like being that kind of bird. But what about in other cases? So, and the point is, let me just, okay, 1 second. Um, so like, how are we gonna deal with that misclassification for the whole data set? I mean,
So,
we can do it like automatically, just make it sure, like, it'll say like we have like five five audio chunks that we gave to you, and you told us, okay, that seems like be like in this way. So we can follow your rules as being our advisor and expert. Can be like based on that approach, or we can discuss another approach.
what could be another approach?
Mm, just make I don't know right now. Maybe just like if we have the song, let's say of 21 seconds, and in between there is one species that is not in your list.
Yeah.
So we still count it. And like I said, like from 0 to 12, that's Hume's Warbler. From 12 to 15, something else. And from 15 to 21, still Hume's Warbler. So
Yeah.
we kind of um we assumed that that could be the Hume's Warbler. And that's its kind of misclassification, because the whole song start and end of one species, and in the range of this song, like one misclassification. So we can delete it, just like we delete this species, or we can put it as a Hume's Warbler. So it can be
Mhm.
like two, like a fork of doing that. So, or you can tell us like what's the best approach.
Um,
What do you
uh,
think?
can you tell me again, if you have one, let's say, 20-second recording, then what's the sort of output you get? Do you like get a list of species that's in there, or just like one species overall?
Um, 1 second, please. So let me open up the file and I'll show you what are we talking about. So probably it will be easier. 1 second. Yeah, just takes a little bit. Okay.
Also, I think each file is like 15 minutes, right? 15 minutes long, I think.
Each file is 15 minutes long, right? For like one audio bench, and then like we have like a lot of them. Yes,
Yeah.
and as Vanessa said, so like we analyzed all of them you provided to us. So we're still waiting for the rest of high elevation because
Yeah,
it will give us like the complete picture, like the
100%.
full
Yeah.
picture. Yes.
Yeah.
So and the analysis will be full. Okay, let me share the screen. Okay. Okay. So can you see the spreadsheet?
Yes.
Okay, so let me. Okay. Okay. You see what we meant, kind of. So like, okay, yeah, let's from here. Okay, so that's the audio song, right? Song from starting at the second 147 and ends at 159, and we see that Himalayan blue tail, which is habitant, right? Like it's one
Yeah.
is singing, and then like in between, we have the says Phoebe that is
That's
zero.
not that's not even Himalayan bird. It's just misidentified.
Yes, exactly.
Okay.
But the point is, it's between the son of the species we
Okay.
have right here.
Yeah.
So like,
Right. And
we can delete it, or we can assume that this is not a says, but still Himalayan blue tail, and we can uh, not drop the observation, but make it as a Himalayan blue tail, because it
Um,
looks like it is a Himalayan blue tail as an assumption, but we cannot tell.
yeah, it could be some other bird singing as well in between, and because of the low volume or something like that, the model misidentified the bird.
Uh,
So
let me
I mean,
show.
we could just keep it, and then when we actually analyze the data, we can clean the data when we do post processing.
The question is, we cannot analyze the data after before clean. So we have to clean the data and then we have to analyze. So it's not like the opposite way. We analyze and then we clean. So we have to understand what are we dropping, what are we adding, what we are merging. So like making sure like the data set we are working, we are analyzing, it is reliable, it's cleaned, it's like all set, and then we do the analysis. Like let's say, can you see here? Just like I can just point it out to you.
Yeah. Okay.
So, uh, yeah, so that's the song, like from 21, like,
Can
and
you explain what's 21 again and what's 24?
so like that's seconds. So we have a file, let's say 15 minutes chunk, right? And
Yeah.
on 21st second,
Okay.
the
Got
model
it.
identify a sound. So
Mm-hmm.
like, and it all comes by 3 seconds chunks. So like from
Yeah.
21 to 24, 3 second audio chunk, it
Yeah.
identifies as a Himalayan blue tail. And
And
then
if
from
you
30,
if you increase the confidence, then do you get rid of those species naturally, or they still persist?
right, which is what I was gonna say. That other example that Andre showed, that confidence level was pretty high. It was like 0.78 or something.
Yeah.
But the expectancy, like the habitant value was 0. So we know that it's not supposed to be there. It's not a Himalayan bird, but the confidence level is pretty high. So that's why it's a little bit at a crossroads here. And like even here, it shows like Pacific wren. Pacific wren, is that even, that's not a bird that's in the Himalayas, right? Right. And then
No,
we
no.
see so many instances of it, and we're
Yeah.
seeing like instances like 0.81, right?
Mm.
Confidence.
Yeah.
So this is where we get a little bit in the weeds or confused about how to proceed, because
Uh,
it's like, oh, they're
so
they're unlikely to be there, and do we just throw out every instance where it's unlikely to be there? I don't know if
yeah, I mean,
that doesn't
what if
really.
you make confidence interval like 90% or something?
um
Vanessa showed you the plot. So like
yeah, so
when
we
we do
have,
like, yes, go ahead.
no, you can go ahead, Andre, you can go ahead, sorry.
No, no. So like when the confidence level increases, yeah.
Hmm.
So first of all, the number of the observations decreases. Let's say from 0.5 to 0.9, it comes from 1.5 million to 600,000. So in this case, it means we are missing 900K sounds. That's a lot. And like in the majority, at least 75% of all these 900, which is like what, like more than 600, right? Like almost 700. It's the observations for the birds we have in the Himalayas, in the Himalayan field, right?
Yeah.
So, but the confidence levels is going up, and the percentage of unexpected species is going down as well.
Yeah. So you think there is some trade-off, and we need to find out what is the good
Yes.
middle point, right? That's
Yes.
the question. I would rather choose to have more robust data without assuming anything rather than, have to assume something. So I think that's more sort of clean data without we have to manually assume that, okay, this might be some other species singing, but it's probably blue tail. So maybe you can bump up the confidence interval a little bit higher and see if you can see reduction in unexpected species.
Oh
Well,
yeah,
we
I mean,
can
we
just
definitely
drop them.
see that. Yeah, like I mean, if you look at this plot, we definitely see
Yeah.
at higher confidence that this orange line here decreases. So that's definitely a thing that happens, but then that also decreases our number of data points that we have, right? So it's like we're just trying to find like a way to maybe throw out some of the outliers. So
Yeah.
like if we have a bird that's in the middle of our audio set that's clearly not doesn't belong there,
Yeah.
on what grounds can we kind of clean it out and take it out so it's not even a part of it and then process it and put it through BirdNet?
Can we the birds that are not there in the Himalayas, in the Western Himalayas particularly, can we just get rid of those species and just have data?
Yeah, we can totally
Uh,
do that. Yeah.
so is that something that you guys would prefer? I mean, is that something more logical to do than, bumping up the confidence interval?
Um,
The
and we could
question
theoretically
is
do both.
the trade-off.
Yeah,
Yes.
the
So
trade-off,
like
right?
is here, like on the plot, we can see kind of the best trade-off could be like on 0.8, because
Right.
Okay.
like the number of Hume's Warbler and the number of unexpected species kind of matches like at this
Okay.
point, and we still like got the high confidence level for like all the species. At the same time, 0.8, it will be like maybe like 700K species in general. So we're still missing a lot, a half of all the observations. So we have to understand what is the purpose, like to get as many false positive and true positive sounds of all the birds, or being like precise of getting only the sounds of the birds we are like very confident in. So like just like capture as many as we can. So we
Yeah.
drop all these unexpected species. Okay, that's the solution. Why not? But then we have to like just understand what we want to get, and it's on you,
Okay.
unfortunately
But yeah.
for you.
And the tough part is we also don't know. I mean, we've been trying to do research on figuring out where this confidence number comes from. You just said it in BirdNet, but like what are the rules? What are the you know metrics basically to come up with this number? But we don't really know that either. So we can't even tell you, is that probability also based on geographic location? Like we don't know that either. So like it's
Yeah,
stuff
also
like
I
that
think
that we're
the
trying to
other thing
figure
is
out.
most of the species there, they may not have models to, recognize songs for most of the species there. So it might be tricky for the model in the first place. That's why you're getting a lot of wrong IDs because they just simply do not have that data, I think, in BirdNet.
Yes,
Yeah.
because the BirdNet model, I guess, has only data set for 1,000 species. That's
Yeah.
it. Even a little bit less, like 949 is, I can recall correctly, which is like quite a few if we count the total number of all the species.
Yeah.
But we have what we have, and it's better than nothing. Absolutely.
Yeah, so I don't really understand what's the real problem is, but what do you guys think should be the next step? Yeah, I would go with, I'll ask Ben also, but what do you guys feel? What is the best way to handle this?
So the question is, do you want to get as many observations as possible, even the observation could be false, or you want to be sure that if we catch the sound and we just don't pay attention to any other sounds, but
Mm-hmm.
we are sure that these sounds belong to a specific species,
Yeah,
but we still we're losing a lot of sounds data.
I think that's fine. We still have enough confidence to tell that at least we know what we're saying. So I think that's fine to have a higher confidence and knowing which species is singing rather than assuming it. I would go with the second option, I think.
Mhm, mhm. Okay. So it looks like 0.8, 0.9, 0.8 is like kind of good trade-off point.
Okay.
Yeah, so I was thinking also, just looking at what
Yeah.
we've looked at so far, it looks like it's a good trade-off point.
Okay,
Yeah.
perfect.
Yeah. I think that'll be great because false positives will be a problem later. So I think it's good to have clean and robust data rather than assuming uh something that we're not sure of.
Okay, cool. So we're doing like on the 0.8, then we clean up the data, like all the stuff, we do the analysis, and we provide you the summary for the analysis. And the next step
Yeah.
is gonna be like we build up the model only based on the Hume's Wolber's sounds, and we just run through whole like all the data you gave to us, and
Mm-hmm.
then we can compare only how good or bad is our
Yeah.
model, or like we can get some metrics.
Yeah. Yeah, I'll try and get you the high elevation data as soon as possible. I've been talking to my field. There's some confusion because it's something in the field diaries that we have written about audio moss that we're not sure what's going on. So they're cleaning up the data. I mean, they're basically sorting the data and hopefully we'll have data in few days.
Perfect.
Yeah.
Sweet, thank you.
Yeah, so even I think within low and mid elevation, because it's not really 1 and 2 elevation, it's like a band of elevation or a continuous elevation. So even within those two bands, you should see some patterns, I believe, for now.
Yeah, I think we saw. I'm interested to see the high elevation.
Yeah, there'll be much reduction in number of species up there. It's pretty extreme.
Yeah.
I have a
It's
question.
And is this
Yeah, go
sorry,
go
no, go
ahead.
ahead. I
I'm
was
sorry.
gonna
No,
ask a
go ahead.
non-related. I was gonna ask a bird question.
Yes, go
I was
ahead.
gonna ask about this. So is this Western crown warbler really common? These other
uh,
warblers? Are there a lot of warblers that live in that area?
it's so Western crown is definitely common, but common only in the lower elevations.
Oh, okay.
Not so much common in the middle elevations. But Humes is also more common in the lower elevations. So, but it's maybe Western ground is singing more. That's why there's more
Oh,
detections. So it's not really
okay.
the reflection of density, it's just how many times they're singing.
Right. We've also I cleaned the data a little bit in that regard. I like anything that was like a continuous song, I shortened to just one data point
Yeah,
for this, just so I could get a little bit more of an accurate count. But I mean, they could still be independent instances of them singing, the same bird singing. But okay, that's cool. I was just curious. Um,
yeah,
Yes, and also one question. So we are able to capture songs or calls of other birds right before Hume's warbler is singing and right
mm,
after. Let's say like, is that information interesting for you or not? Because let's say like we see like what it could be like blue tail singing
yeah,
right now, and just right after 3 seconds, Hume's warbler is also singing. Or like before, like Hume's warbler is singing, and like in 3 seconds or 6 or 9 or 12, like some bird is singing as well. So it could be like kind of interaction, communication,
yeah,
probably.
100%. Yeah, yeah. I mean, if,
So
if you if you see some pattern like that, just share with me and I can think about it. But if you see, so there's something called a sound partitioning in birds. So imagine 50 species of birds singing in a small area, and not all species can sing at one time, right?
Yes.
Because that will be mess. So some birds sing early, some birds sing later. So if there's some partitioning within that time window of time, then that will be great. I haven't thought about it yet, but if you see any pattern, then we can think about it.
No, we can do that. We already wrote the code for that pattern. The question
Okay.
is, so like we can do like the window 3 seconds, 6, 9, 12, like
Hmm?
15.
Yeah.
What do you want? Like what could be the like you can give us like, any options based on your experience.
Oh, you
Or
mean when one bird starts singing and when it stops?
yeah, so like the main point is Hume's Warbler's uh sound, and then we can get the window after and before. Give me 3 seconds, 6, 9,
Oh,
12.
okay.
So like we can go we can do all of them like 3, 6, 9, 12, or like 15. But maybe you just recommend us like what is
Yeah,
the maximum or what is the minimum
I think
window?
maybe like 10 seconds will be, or maybe like 9 or whatever. 9 is the thing? Okay.
Yeah.
Okay. Yeah, maybe we can
Yeah.
try with 9.
Okay, so 3, 6, 9 then. Okay, so we get like three of them.
Uh, I think 3 will be immediate. Maybe they stop for a while and then maybe other species will start, but maybe like 6, 9 if you feel.
Okay, perfect.
Yeah,
Okay.
Yeah, I think
just check with one of them and see if there is actual pattern, then we can explore more probably.
Okay.
uh yeah, I mean I can only from my experience of because I had to like manually label all the Xenocanto data
Oh, okay.
and like listen to all the and like the buzzes will they kind of last a little while, like a little longer than 3 seconds because it's like that screeching sound, right?
Yeah.
I mean, this is the plot of how long the songs were that BirdNet was detecting.
Mm-hmm.
And so it was just I mean, this is going to be 3 is going to be the most common, right? Because that's like the intervals that they detect. But
Yeah.
I mean, they sometimes kind of go into, I don't think it's going to be any more than 10. Um, but yeah, I think like 6 or 9 is a good number
Yeah.
because it does go a little longer than 3 seconds, like some of the screeching,
Yeah, but this will be
or the
after the
buzzing.
song is finished, right?
Yes, right. So
Oh, you're
the
saying after. I
the the
misunderstood.
the
Sorry.
the, the main idea is like within this window, who's singing after or before Hume's Wilbur. That's it. So like I said, like
Oh, okay.
in the range of 6 seconds, we
Yeah.
got those pieces. In the range of 3 seconds, we got like the number of those pieces. So
Yeah.
that's the main point. Not like just like yeah the length of the song, but like who's communicating with Hume's
Exactly.
Wilbur, if we can say so.
Yeah.
And
That'll
is
be
that a thing that
exciting.
birds do? Like they talk even outside of different species, and especially like when we're looking at like territorial whatever. I'm just
Yeah.
curious. Like, is that
I mean,
like a
it's
thing that
interesting.
happens?
I mean, I don't think many have studied anything, but usually there's competition between different birds for soundscape, you know.
Right.
Imagine sound as a space, a circular
Mhm.
space. Within that space, different birds are singing. And if
Okay.
one bird is continuously singing, then there's no space for other birds to sing. So they do have some interactions going on, and we still don't understand how that pans out in
Oh,
nature.
so they don't like it when other birds are singing at the same
Exactly.
time.
So do you guys
Oh,
know cicadas? Cicadas are very noisy insects, right? And when cicadas are singing, birds just avoid singing during that time in tropical forests because cicadas are so noisy, so loud that even if birds are singing, their partners or their other mates wouldn't hear birds singing. So they just avoid singing when cicadas are singing. So there is some interactions even
well,
across.
that makes our job a little easier.
Yeah,
We don't
yeah,
have like a bunch of overlapping birds. But, oh,
yeah.
okay, cool. I didn't know that.
Yeah, it'll be cool. I don't have any hypothesis for what birds sing before and after, but if you can find something, I think that'll
We
be
can.
awesome. That'll
We
be
can.
Okay.
awesome.
That
Yeah.
Yeah,
definitely yes. Okay,
yeah,
perfect.
yeah.
Cool. Sorry, I feel like we took up a lot of the time.
Oh no, we still got
Questions.
time. Great. I'm excited about this before and after thing. And yeah, I'll try and get the high elevation data as soon as possible. I think it'll be a good comparison with what we have now and with high elevation because there'll be a drastic drop in the number of species. Very few species up there compared to low elevation. So western crown should permanently drop by the time you reach higher elevations. You shouldn't hear that there.
Yeah, it looks like that even on the what we have so far. There's like no detection at all.
Where in the middle elevations? Or
Yeah,
just
like
to
anything above 3,500 meters, there's like
yeah,
no detection.
yeah, exactly. I think that's a good pattern. Because we do this survey, we actually walk through forest and hear birds and then note, okay, 3,500 Western Crown Warbler. But it's just like one instance we walking there, right? Because these audio
Right.
mods are listening to birds every day for like 4 hours or maybe every 15 minutes, 4 hours. So I think it'll be much robust estimate of which species live where. So I think it's
Right.
really interesting. Yeah.
Yeah, I know it is really cool.
Yeah. Awesome. Great. Yeah, we
So
can.
should we throw out the like not local species altogether? Like that we don't like Pacific Ring, because there's so many instances of some of these.
Yeah, I think we can just get rid of them. Pacific
Just to
Rim.
completely take them out.
Yeah,
Okay.
yeah. I think we still will have enough data to say something. I think it's better to have uh data that's robust enough to say one good thing rather than assuming 50 things and saying 10 different things that are we not confident about.
Okay, cool.
Yeah, awesome. Yeah, thanks for working on this, and yeah, very exciting. Yeah, we'll be on touch on Slack. I do have my exam lined up in 2 weeks, but I'll be on and off on Slack checking stuff. But yeah,
Good luck.
thanks. Cool then. See you guys.
Yeah.
Bye. Thanks all.
Sounds
Bye,
good.
thank
See
you.
y'all.
See ya. Bye bye.